Hey Luke.
Hey, how you doing?
Good. How are you?
Good.
Okay, good. I can take that little sticky down. And I count 15 people here, which is great at this point. Thank you all for coming. A couple Zoom reminders. While Luke is talking, please turn off your cameras and mute yourselves so that we maximize bandwidth. And then when there's questions, if you have a question, I'll try to be watching the chat and raise your hand. And if anybody sees a hand raised that I don't acknowledge, jump in and let me know. Luke, do you want to be interrupted with questions or have everybody save until the end?
No, if you have a question in the progress of the slideshow, feel free to raise your hand and ask a question. I'll try to answer as best as I can.
Okay, great. So our speaker tonight is Luke Leege. Although I've seen Luke's name forever, it seems like I met Luke. I met you once very briefly at Farish one night, and all I could see was you was a nose. You were covered by a hood, and then I saw you at Astronomy on Tap that one night, which was fun. But
Yep. Hey, that was a good night.
thank you very much for doing this. As you know, as Luke's topic is astrophotography for dummies like me, an introduction, and we're all anxious to hear what you have to say, Luke. I'll turn
All
it
right.
over to
Well,
you.
thanks for letting me host this event. It's my pleasure. First off, a little bit about me. My name is Luke, as Michael has said. I've been a member of the ASRAS for over 20 years now. I was fairly active 20 years ago when I first joined, and then life interrupts things and things taper off. But lately, I've been trying to get myself back involved in the hobby and associating with the club. So I was asked to put this presentation on, and I guess we'll get started. So, once again, if you do have a question, just feel free to raise your hand. This is kind of going to cover just the basics. I don't want to get into any of the technical aspects of it because that's just a whole other topic unto itself. So, here we go. So, first question you're probably asking yourself is what kind of equipment do I need if I want to take pretty pictures of the sky? Well, there's a few different choices. Obviously, you're going to need a camera, but the type of camera you have will most likely work anywhere from your smartphone to point and shoots to your digital SLR cameras and film cameras and on from there. You're probably going to want to have either a tripod or a mount. In fact, I highly recommend it. Depending on your situation, you're probably going to need some type of power, either outlet you can plug into, or you're going to need to bring some battery packs with you, or a packaged power support power supply like the Blue Eddy or the Jackeries or something along that line. You may need a computer depending on what type of camera you're using. Depending on how pretty you want your pictures to be and what your purposes are, you're probably going to need some kind of software as well for stacking and processing and enhancing. You're going to want some type of planisphere or some software to tell you where to look in the sky for what you want to image. And you're going to need a few other accessories like maybe a guider or some dew control, or just there's a ton of accessories you can get into. So starting off at the basics with just your smartphone. It's not the greatest tool for astrophotography, but if it's all you have, it'll work. The nice thing about smartphones is you've always got it with you. I mean, nobody leaves home without their phone anymore. So you've always got that in your pocket. If you see something in the sky, take a picture. You can use them handheld, although I don't recommend it because you're going to have longer exposures that are going to induce shake and into the image. So the steadier you can hold your camera, the better. And they're really good for like Milky Way images and something if you want to have a foreground in it. You can compose your shots. Good for brighter objects like the moon or other large night sky objects like maybe M31 or some other larger objects. Orion Nebula would be a good one. Nice thing about the smartphones is you don't need any power. I mean, it's self-contained battery. As long as your battery's fully charged, you could probably take a whole night's worth of images without the worry of losing power. I highly recommend some type of tripod. Doesn't need to be a fancy one, just something you can stabilize your camera with. And then you can, if you're into the app thing and all that good stuff, you can tell Siri to take an exposure without you touching the camera so you don't shake or anything like that. The next step in the line is probably going to be the DSLR or the mirrorless cameras. Very versatile. The nice thing about them is you still don't need a computer. You can store all your images right on the disk in the camera. You can operate them with just a simple shutter release or an intervalometer, which is nice, especially the intervalometer eliminates the need for a computer as well, because you can have it programmed to take X amount of exposures for 60 seconds and do this 100 times, and it'll do it just with the push of a button. Another nice thing about the DSLR cameras is it's not dedicated to astronomy. So you can use it for your vacation camera or family portraits or holidays or just everyday use. You can use it with a standard lens. You don't need to go out and buy a telescope. You can just use whatever kit lens that came with the camera, or you can invest in some other nicer lenses. Obviously, the better quality the lens, the better quality your output's going to be, but you don't need to make a significant investment into equipment to start astrophotography. I will warn everybody, it's addicting and it's some people buy boats and some people do astrophotography. You can use it with most any telescope as well. You may need to buy an adapter to match the camera to your specific telescope, but pretty much any telescope will work with your DSLR camera. And again, you don't need an additional power source. The batteries on a DSLR will typically last 3 to 4 hours, depending on how long of your exposures are and how cold it is outside. But batteries are cheap. You could buy an extra battery or two and you can image all day and all night without any extra power needed. Another nice thing is you get a lot of chip real estate for not a very big price tag compared to CCD cameras. The consumer grade chips are pretty, you could buy a brand new APS-C sized camera for $500-600 maybe even less if you're looking in a used market. You can buy an older camera for probably $100. Some of the cons with that, though, are the consumer grade cameras aren't really designed for long exposure photography, so they will introduce some noise into the image along with amp glow. The larger format chip can cause vignetting in your images, especially if you're only using a inch and a half or inch and a quarter focuser. 2 inch is probably recommended at best for that larger format chip.
Luke, what causes the amp flow
The amp glow,
or
it's
glow?
the amp glow is from the architecture and the electronics. And when they're building the consumer grade cameras, they're not worried about things like that because you're really never going to see it when you're taking a picture of a landscape or a portrait because you're only taking millisecond exposures versus 30 seconds or longer. So that's just heat generated from the architecture of the imaging, not the imaging chip, but the electronics that are connected to the chip. And they just create that gradient across the imaging chip. Another drawback to that larger chip is it's more demanding on your optics. This is a crop of the four corners of a larger image, and you can see the distortion in the stars. They're elongated. Uh, so if you don't have a flat field telescope, you're going to see more of that as you get farther from the center of the imaging chip. You're going to have those uh, defects in your image, basically. Another drawback is there's no real practical way to control the temperature of the sensor. It's whatever the ambient is, and you just have to maintain a larger dark library for different temperatures. If it's 70 degrees out, you need a dark library for 70-degree temperatures. If it's 50 degrees out, you need another dark library for that, and so on and so forth. Obviously, the colder it is outside, the better performance the chip's going to have because it's colder. It's going to be a little less noisy. It will help reduce some of that ant glow as well. But uh, in the practical sensors, I've seen people rig up where they built a cooler and put their camera in it and put some TEC cooling on it. And I mean, while it does work somewhat, it's not, in my opinion, worth the investment to go through that hassle. Just maintain a dark library. Another drawback is the factory installed filters on the camera itself. They can minimize the red response. So if you're shooting a hydrogen alpha rich target, you're not going to get as much response as you would hope. You could still do it. It still works. You just need to take more images to process and stack together to bring out that detail. But and some people had their cameras modified and had that filter removed, but then you need to buy another filter to put back in if you want to use it for daytime use. The nice thing is all these cons can be dealt with in post-processing. The next step in the line is going to be the CCD cameras, or now the more modern CMOS cameras. I see we have a question. Uh,
James says,
struggling.
since the large formats like FF or ASPC camera sensors are not large market like mobile camera sensors, which has many upgrades and revisions in a short time frame, do you believe we will see revisions or upgrades anytime soon in the future? Or will they still be rare?
As far as the chip sizes in the consumer grade DSLR cameras, to be
Let me,
perfectly honest with you, my DSLR camera is probably 17 years old. And that's about where my knowledge of those ends because I kind of don't really use those anymore. to be honest with you, I don't know if I understand the question completely either. But I mean, technology is changing rapidly, so
Yeah.
there's advancements every day. But I really can't speak to that with any certainty. So moving on to the CCD CMOS sensor cameras. The nice thing is there's a wide variety of imaging chip sizes to choose from. They're obviously all going to impact the overall cost of the camera. So when you're shopping for a digital CCD or CMOS camera, you're going to want to try to match the sensor size to your telescope. If your telescope only produces a 40 millimeter imaging circle, you don't need a full format camera because you're going to be cropping out all that vignetting that you're going to get anyway. So, and also chip real estate costs money. So the smaller sensors are obviously more affordable. The nice thing about the CCD cameras is you have active temperature control. You can set the camera to set your sensor at a certain temperature. So you don't need to maintain as large of a dark library. You still need to shoot dark frames, but you can just set a dark frames at like 0 degrees Celsius, and maybe for summertime you might want to go to 10 degrees Celsius and just create a dark library for those two temperature ranges instead of needing a dark library with 5, 6, or 7 different temperature ranges depending on when you're out imaging.
There's another question in the chat. Is there a difference between CCD and CMOS?
There is. CCD is still technology. The CMOS sensors are basically a DSLR camera, the same type of technology. Uh, Obviously, they're more affordable now because of the same chip is made for different purposes. It's more the circuitry and the circuit boards in the CCD cameras are more sensitive to the heat and things that cause that amp glow and other things. So it is a different technology, but similar results. The most important part being the ability to cool, though, is where some of your biggest benefits are. With that cooling, you get a lower noise in your images. The chip itself doesn't create a lot of noise in the image to begin with. You have a lower pedestal for the noise, and you're going to be shooting above those pedestals to capture the photons of light. Most of the newer ones don't have a shutter, so that kind of sounds a little trivial, but first of all, the shutter actuating, it's one less thing to worry about breaking, shutter failure. Another benefit to it is when you're shooting calibration frames and you need to shoot flat frames as part of that calibration, a shutter can actually skew your bias, or excuse me, it'll skew your flat frame because while the shutter's actuating, part of that sensor is not receiving the same amount of photons as the part that opens first, if you follow what I'm saying. So without that shutter or a rolling shutter, your imaging chip is going to get that same gradient of light across the whole chip uniformly illuminated. So it just makes the process a little easier of shooting flat frames. Not that shooting flat frames is difficult, but you need to understand what's going on when you're taking those frames and how it affects your calibration on your final image. They're a lot more sensitive because they don't have those factory installed filters. The UV and IR cut filters can lessen that red response. And you can choose a monochrome camera as opposed to a color camera. So if you want to get into shooting narrowband images, it's a lot better to do that with a monochrome camera than to use a color camera and then use another filter on top of that to filter the narrower bands that you're trying to shoot in. It's a lot easier to capture that narrow band with a mono camera in a shorter amount of time. So you don't need to shoot a 5-minute exposure. You can maybe reduce that to 2 minutes. Some of the cons, they can be very expensive. And I'm talking tens of thousands of dollars, depending on how much you want to invest in a camera and how much chip real estate you want to buy. They will need a computer to operate in the field. Something's got to tell it what to do. And it's going to require field power as well, either a battery pack or an AC outlet if you have that luxury. Spacing on these, same with a DSLR, but you may need some special adapters and spacers depending on if you're using corrective lenses in your optics, like a field flattener or a focal reducer or other corrective lenses, coma correctors and things like that. Spacing is critical between the imaging plane and that corrective lens to get the maximum performance out of that corrective element. It's pretty much dedicated to astronomy. You're not going to take your CCD camera out to Yellowstone Park and shoot a picture of Old Faithful. Just probably not going to happen. I mean, if you really wanted to, you probably could, but it's not practical. Similar with the DSLRs, the larger format chips are more demanding on your optics as well with those same drawbacks. The latest thing now are the smart telescopes. I was fortunate enough to, my daughters bought me a little C-Star 30 for my birthday. Haven't had a chance to use it yet, unfortunately, because we live in Rochester, but these things are great. I mean, it's extremely portable. You can carry it with one hand. Lightweight, comes in a nice little case, comes with its own little tripod. Everything is self-contained. Everything you need to do to capture an image is in that unit. Computer, imaging chip, the telescope, the go-to and the tracking, it's all built into it. It's also got its own built-in battery. So you charge it up before you head out. And I haven't tested it yet, but I suspect you should be able to get a good night's of imaging out of it without the need to recharge it. If that's not the case, you can still power them in the field with an alternative power source as well. You can use it in the daytime. The app has a bunch of different features. You can set it to take time-lapse exposures if you want to watch a flower bloom or things like that. If you have a bird feeder, it'll actually track any movement around that bird feeder. I'm not sure how well that works yet, but it's on the app. It looks like something that would be great for outreach programs. You can have multiple people looking at the same image at the same time. And it does live stacking, so the more exposures it takes, the better that image is going to look on the screen.
Luke, Tonya asks, so the smart telescope can replace a regular telescope, and is it costly?
No, in fact, that's one of the pros I should have put on there is they're very affordable. Um, this particular unit that I have, the C Star 30, I think it's under $400. There's some other bigger units that range $500 to $600, but in the overall scheme of things, when it comes to astrophotography, $700 is a bargain. But again, they're easy. I've spent a couple hours with it, just playing around with it, and everything on the app. It's very intuitive. Uh, there's tutorials built into the app that tells you how to do different things. You just basically set the thing down, turn it on, and it knows where it is. It knows what direction it's pointing. So when you tell it to go to Orion, it's going to go and slew pretty accurately to that target. But then once it gets in that direction, it's going to plate solve itself and center that image precisely. Very slick. I'm looking forward to trying it out. And it's going to be a companion that I bring with me every time I go out to image with my larger telescopes. I'm still going to bring that with me because it is so easy to set up. You just set it and forget it. The cons, it's really not made for planetary imaging. Something for planetary imaging, you're going to want a lot longer focal length. And it's more for like a wider field of view, like large galaxies, the Orion Nebula, other things. You're not going to really get a lot of detail on small planetary nebula or real faint objects that aren't don't have a big apparent field. So again, it's better suited for larger objects. The next step in the astrophotography world is mounts. You're going to need some kind of mount, anywhere from a German equatorial to a fork mount. Whatever you're able to afford, you're going to need something. It could be as simple as a fixed tripod, a barn door tracker. You could build a barn door tracker yourself for cheap, and you probably got everything you need laying around your garage that you would need to build one. Alt-Az mounts or a fork mount is another option, although an Alt-Az mount, not the best thing for astrophotography, but it'll still work if that's all you can afford or if that's all you have. Ideally, you'd like a German equatorial mount, something that's going to track accurately the movement of the object across the sky. And the latest thing nowadays is the strain wave gear mounts, also known as harmonic drive mounts. Essentially, it's a German equatorial mount with a little different gearing technology, and some people say they're better, some people say they're worse. I'm indifferent at this point. I have both, so fixed tripods. The nice thing about them is they're very portable. They're inexpensive, easy to use, and they'll work with DSLRs, smartphones, and even the smart telescopes. The nice thing about the smart telescopes is you can actually polar align those as well and get a little better performance out of that smart telescope. Some of the drawbacks are obviously you don't have tracking with a fixed tripod, so it's going to limit your exposures to maybe 15 to 30 to 60 seconds, depending on where in the sky you're pointing and the focal length of your lens. The lighter duty models can be very shaky, so you're going to definitely want some type of a remote shutter release. Barn door trackers. This is kind of like old school technology. Some of you may not have ever even heard of this type of device, but it's essentially a couple pieces of wood, a hinge, and a threaded rod. This particular specimen has a clock drive on it, but that's a luxury. The nice thing about the barn doors are you can make one right at home. They're very inexpensive, and you don't need field power. It's just a matter of that threaded rod. It's a quarter 20 threaded rod. I forget what the math is, but there's a certain. I think it's if you turn it a quarter turn every 15 seconds, that's roughly equivalent to the rotation of the Earth. So you just every 15 seconds you get a little turn and keep taking pictures. Some of the drawbacks, it's limited to a shorter focal length lens. You're not going to put a 1,000 millimeter focal length lens on a barn door tracker and expect it to give you acceptable results. But 50 millimeter lens, 100 millimeter lens, uh, uh, kit lenses that come with most DSLRs, going to work great with these. Uh, you do need to reset them frequently. You only have so many turns on that shaft before you need to reset everything and start over again. Next type of mounts are the Altaz mounts. I'm sure everybody's familiar with the Meade SCT telescopes in the fork-mounted configuration. They will work for astrophotography, although I don't recommend them. Some of the pros of the fork mounts are typically they're less expensive than a higher quality German equatorial mount. They're pretty simple to set up. You don't need to polar align them, so you just kind of level them and turn them on and let the software calculate its position and get it aligned, and you're good to go. Like I said, you don't need to polar align them. While you can use them for long exposure photography, it's not ideal because of the mount tracking in 2 axes. It's going to impart some field rotation in your images as the exposure goes on. The longer exposure, the more you're going to notice that in your pictures. Is it acceptable? I mean, that's up to the user. Some people are just looking to put a pretty picture on Facebook and have their friends say wow, while other people want to get into the scientific details and present something that's APOD acceptable. You can polar align them using a wedge. It's another accessory that you would need to buy, but you can polar align them and then eliminate that field rotation. It's not simple to polar align a fork mounted telescope from my experiences anyway. I gave up on it. The most common telescope mount used for astrophotography is going to be the German equatorial mount. A couple different types here. I'm not sure if that picture is clear on your guys' end, but this is just like a typical CG4 mount. It's manual. You can just turn those dials by hand to track. And then you get into the more complex computerized telescopes, or telescope mounts, excuse me. Nice thing about the GEMs is they come in a wide range of capacities, from low budget all the way up to, oh my God, what are you thinking? They'll accommodate pretty much any kind of telescope or lens. They only track in 1 axis, so you only need to worry about the tracking accuracy of your right ascension axis. The declination doesn't change when you're polar aligned, so you only need to track in 1 axis. Some of the drawbacks, again, they need to be polar aligned. Some of the new modern software is making polar alignment very simple. A matter of just taking a picture and computer will tell you to move the mount this way a little bit, and you take another picture, and you do that 6 or 8 times until you're perfectly polar aligned. Versus back in the old days when you needed to drift a line, which could take anywhere from 20 minutes to a half an hour, and you would get a stiff neck trying to do that. They do need counterweights. It's very important that your mount is balanced. So you need whatever your telescope weighs and your other accessories. You should have enough counterweight to balance that right ascension axis, as well as your deck axis, moving the telescope back and forth in the saddle to balance in that axis as well. But you will need counterweights. You're going to need field power. The latest trend now is the strain wave gear mounts. It's basically same as a German equatorial mount. You still need to polar align it. It tracks in right ascension. Some of the same pros and cons of the gem, with the exception of the nice thing about the strain wave mounts is you don't need a counterweight within a reasonable load range. If the mount's rated to handle 20 kilograms of weight, you could probably increase that to 30 kilograms if you add 10 kilograms of counterweight. So they're a little simpler to set up, I guess. And one less thing you got to carry with you in the field. Counterweights can get kind of heavy. Next thing is telescopes. If you're not going to use the camera lens, you're going to need some kind of telescope. There's a ton of different telescopes to choose from. Too many to even mention here tonight, but to touch base with some of the basics, every telescope has its pros and its cons. It may be cost, it may be complexity, it may be the telescope design isn't suited for this particular purpose that you want to use it for. Price range and performance. I would recommend starting out to stick with a shorter focal length telescope. It's going to be easier on your mount. It's going to be easier on the tracking. It's going to be easier on taking longer exposures. Probably going to be a little less expensive. It's going to be lighter, so you don't need to have that mount that has a 100-pound capacity. You can image with a mount that's rated for maybe 15 or 20 pounds. Most common is going to be obviously the refractor. When you think of a telescope, I think everybody in their mind pictures a refractor. If not, you should probably go see a doctor, because I'm a telescope. I'm a refractor snob, I guess you could say, but just kidding. Refractors are simple to use. They can suffer from chromatic aberrations if you don't have a high quality triplet or quadruplet lens design. You will get some false color. Reflectors, like your standard Newtonian telescope. I'm sure everybody is familiar with the Newtonian design. Their pros are they're a little less expensive than refractors. One of their drawbacks are they do need to be collimated, especially if you're moving them around a lot. If you're packing them in your car, then driving to a remote site, and that mirror's getting bounced around, you're probably going to want to collimate every time you set up. And not all Newtonians are designed for imaging. While they can all be used for imaging, most of your optical design Newtonians, the primary mirror is farther back in the tube, so your focuser doesn't have enough travel to come to focus with a camera. So you'll need to take that primary mirror and actually move it farther up the tube, which sounds scary. It's really simple. You just got to drill a couple holes and move those primary mirror clips up the telescope a few inches, depending on how much in travel you need. But just keep that in mind if you do decide to go with a Newtonian design telescope. If you do, I would try to look for one that's designed for imaging because that eliminates that problem. And then your compound telescopes, which are basically a combination of corrective lenses, either refractive optics or correctors, and some type of mirror. And there's just so many different designs. We couldn't possibly talk about them all, but there's most common the Maxitoff. There's Maxitoff Cassegrains. There's Maxitoff Newtonians. Celestron's got a newer Roe Ackerman design telescope, which is basically it's an imaging telescope. I don't even think you can use it for just visual astronomy.
Luke,
Uh,
there was a question about collimation. Is it actually that simple, or can it go south easily?
if you don't have the right tools, it can go south easily. It's something that I try to avoid, which is why I use refractors. But collimating something like a Schmidt Cassegrain, or excuse me, like a Schmidt Cassegrain, it's simpler because you have your uh, collimation screws are on the secondary, and you can do that usually with just a bright star. With a Newtonian, you got to make sure that your mirror is center spotted so that that's centered in your tube accurately, and then your secondary needs to be collimated to that center spot of your Newtonian. And I don't want to scare anybody. I mean, it's the first couple times you do it, you're probably going to screw up, but it's nothing that can't be fixed easily. Usually, there's plenty of members in the club that are familiar with that design and have done it a million times, or have the lasers that you need to collimate them. So I wouldn't let that discourage you if it's for reasons of economics that you need to go with that type of telescope. It's just something that you need to learn how to do, and the more you do it, the easier it's going to become. So don't let that discourage you. Software. Now, this is where it gets into, what level do you really want to get into? If you're just taking pretty pictures and posting them on Facebook, you probably can get away with free software. There's a lot of free options out there. GIMP, which is basically a knockoff of Photoshop. Serial is a PixInsight type software, a little more features. You can stack and calibrate images in Serial. Deep Sky Stacker is a really good free software. It's what I started out with years ago for just stacking images and calibrating. It'll also flat calibrate and dark and bias calibrate your images. And Registax, I'm not too familiar with it because I don't really do much planetary imaging, but that's, I guess, a big software for the planetary imagers. And again, that is free. You can get into the pay to play software. Photoshop, again, they unfortunately changed their model where now it's a subscription based. I still have an older copy of Photoshop that I can still use. It's still fully functional and does everything that I need it to do. PixInsight, it's probably the most popular image processing software out there right now. It's very powerful. Uh, Tons of plugins, tons of actions. It does everything from start to finish, from your basic image calibration all the way to your finished product. I still use Photoshop to do some final enhancements, but PixInsight, it's very powerful stuff. And in my opinion, it's worth I think it's $230 now for a lifetime license. I think it's money well spent if this is the thing that you want to do with imaging. And there's other like APT, and then there's some other ones. There's a lot of paid plugins as well for both Photoshop, PixInsight, and APT. A few of the popular ones that I'm familiar with are from RC Astro, Russell Croman. They wrote a lot of these plugins, and they're fantastic. Noise Exterminator, it's really powerful tool for reducing the noise in your image, especially if you're using a DSLR where you're still getting some noise in the image. Noise Exterminator does a great job of eliminating that. Blur Exterminator, it's great for if you don't have a corrective lens and you have some field curvature, it'll actually sharpen those stars up on the edge of your image and make them more round, kind of get rid of that football effect. Star Exterminator is not really necessary. It's a great tool for, especially if you're doing narrowband image processing. You can eliminate the stars from your narrowband data and just process the narrowband information, and then you can add the stars back in after the fact. And these are all reasonably priced plugins. I don't know the exact cost off the top of my head, but I think you could buy the whole bundle of all three for $150. And all these have free trial software too. PixInsight and all these Blur Exterminator or RC Astro plugins, you can get a free trial just to try them out to see if it's something that you want to invest in. Accessories. I don't think we have enough time to talk about all the many accessories that you could use in this hobby. But just to touch base on some of the more common things, guide cameras, either a guide scope or an off-axis guider. Focus motors are nice to have, so you can use autofocus. Camera rotators, while not a necessity, it's nice. You can frame your target better. Filter wheels, if you are shooting monochrome, you're going to want a filter wheel. Filters, even for color cameras, you can buy a filter drawer and use like dual band filters or just a light pollution filter. And apparently my spell checker didn't work, but that should be controllers, something like either a computer, or now they have all-in-one units like the ASIRs, or there's Stellar Mates, and Stella Vita, I think, is another new one that just controls the camera, the mount, your focus motors, and all those other accessories as well. All right, does anybody have any questions?
There were comments that Affinity is a good Photoshop alternative and free for most features. Affinity Photo.
Yeah, that sounds like one that I've heard of. Affinity Photo. So, I mean, the free stuff is a good way to start and see what works. With any of this software, there's going to be a learning curve, no matter if it's paid or free. You're going to have to invest some time into just learning how the workflows go. The workflow is important. Like when you're removing noise from your image. You want to do that while you're still in a linear state versus a stretched image. Same with Blur Exterminator and any other deconvolution type software where you're trying to sharpen your stars. Uh, there's certain points in your workflow that you need to do that. If you do it in the wrong sequence, you're not going to get the best results and may actually make your image worse. So YouTube is your friend. There's so many different tutorials out there on pretty much anything you want to learn. It's on YouTube. If it's APT or Cyril or any of the free stuff or any of the paid stuff, there's many tutorials. Uh, I don't know if any of you have heard of Kuv the Lazy Geek. He's got a lot of videos going over pretty much every point of astronomy or astrophotography. Excuse me, astrophotography from just product reviews to how to process images and all kinds of stuff. So he's a good resource, and there's many others out there as well.
Hey, Luke, question for you.
Yes.
Did I misunderstand you? Did you say the C Star 30 could be used visually, or can you share images with it, or like you can with that with that iScope that or with that really cool eyepiece that
the Pegasus?
Yeah, is it like that or not?
No, it's a little, well, it's different. You can't use it visually. It doesn't have a screen on it.
Oh.
Everything is sent to your phone.
Okay, thanks. Everybody's phone though.
If you join that hotspot, yeah.
Oh, that's cool.
So don't quote me on that. I can't verify that 100%, but from everything that I've seen on the app, it looks like you can share that connectivity to that device.
But it's your phone. But you use your phone. That's what's really handy. You've got a phone in your pocket, right? That's neat.
Yep. As long as it has Bluetooth, it'll connect to it.
Thank you.
And I haven't gotten into all the nuts and bolts of it yet, but I think once you connect it to Bluetooth, you're able to put it in station mode so you can connect it to your Wi-Fi, and then you can control it remotely from anywhere in the world. Still reading up on that, but that's my understanding of how it works.
That's amazing.
And a lot of these new Astro controllers have similar features where you can control them remotely from anywhere in the world. Personally, I'm using the StellarMate Pro device, and that runs my power supply, so it distributes the power to all my devices. It has dew control, so I can just plug in my dew straps to the controller, and it regulates the output of those based on the dew point and the temperature. It has a sensor, so it measures the air temperature and the relative humidity. Several USB ports to connect all your devices to, along with a focus motor drive control. And it's got built-in GPS and Wi-Fi, along with an app that you can control everything with a. Theoretically, you can use your phone, but it's too small of an interface. You would need at least like a 10 or 11-inch tablet to use the app. But it's similar to the ASIRs, but I think it's a little better in that you're not locked into ZWO products with the StellarMate, and it has a few more features that the ASIRs don't have.
I wanted to just comment that ASRAS has a Discord server that a lot of the astrophotographers hang out on. And if you're interested in astrophotography, that's a good place to go to. A lot of the conversation is pretty technical, but people will back up and explain stuff to you if you'd like. And if you want to get onto that server, just email me and I can send you an invitation. Luke, on that server, there's a lot of conversation about back focus. Can you explain that?
So back focus is important, but it depends on your optics. So most cameras that you buy nowadays, like the ZWO, they come with the accessories needed to give you 55 millimeters of back focus.
And what is it? What is it? What does it actually mean? How do you measure it?
So I don't know who came up with 55 millimeters, but somebody decided that's the industry standard for back focus for corrective lenses. So if you don't have a field flattener or a coma corrector or a focal reducer in your imaging train, just throw all that back focus nonsense out. It doesn't pertain to the camera itself.
Hmm.
It's irrelevant. Uh, what's important is your corrective lens is designed to perform at a certain distance from the imaging plane, and that distance isn't really universal. So I don't know why they came up with 55 millimeters, but that seems to be the standard. But the back focus you need to worry about is what the corrective lens manufacturer specifies. And that varies. Some are 72, some are 98 millimeters. Apparently, a lot of the more common ones are 55 millimeters. So that's why the manufacturers give you that specific spacing. But it can vary, depends on your optics. And if you have a flat field telescope already, then you don't need to worry about that either. Like most of the newer quadruplet telescopes that are coming out that are either like a modified Petzval design or something that has a built-in corrective element, back focus is irrelevant. It's nothing to worry about.
Thank you. Other questions or comments? Well, Luke, thank you very much for tonight. This was really great.
Thank you,
Yeah,
Luke.
Really
uh,
enjoyed it. Mary says we need a part two.
I'd be more than happy to get deeper in. I think it would have to be more compartmentalized with either telescope specifics or mount specifics or different aspects. But I'm on the Discord group. I'm happy to answer any questions there. And hopefully, I'll be visiting Ionia a little more frequently and setting up and sharing whatever I can at the observing site.
You know, part two could be a practical too. We could actually schedule you for part two at Ionia, and you could bring some
Yeah.
of your equipment and show it off there, and people
So
could bring theirs if they've got it.
I did set some things up here in the background, but I don't know if my lighting and everything is really doing any justice. But there's just a few different refractors and different mount types, along with just a smartphone mounted on a tripod
Nice.
with just a rubber band to hold it on there. You don't need any fancy mount to hold it on there either. So, but yeah, something on site would be great.
Yeah, that would be terrific.
Starfest is usually a good place to exchange information and ideas. So
Yeah,
hopefully everybody gets to attend this year.
that's a good idea. July 10th through 12th.
Is it in the books now?
Yes. Yep. 10th through 12th. All right. Any other questions? Last call. Luke, thank you very much.
All right, you're welcome,
Really
everybody. Have a
appreciate
good
your
night.
time and effort and
Good night.
expertise.
Thank you.
Good night, all.
Have a good night.